Hey, and welcome guys to another little tutorial and things. Now in this video I'm going to be discussing how you can throw bonuses to certain classes and to be able to tell what slot it goes into and how we can filter things around. Now what do I mean by filter? Okay, well, we have specific slots that we want certain types of weapons to go into. Now there's a few different ways that you can do this, and there's other ways as well. Not all ways are good and not all ways are bad. It all depends on your game. And that's the main course of it by itself. Now, when I think of slots, I think of conditions. Like, this is condition 1, 2, 3, 4, or condition red, green, purple, yellow, and things. That's how I think of it. So when it comes to how we are going to do in this example, is I'm going to have a method right here. This method is directly responsible for telling the script for this slot to do something. Okay, basically it passes the functionality that we need into the game and goes at it. Well, public weapon. Well, what's the weapon take? It takes an integer and a string. Now, I went with an integer into a switch statement. Now, there's a few reasons why. The reason why I done integers versus strings or any other type is because strings are a little bit heavier. Comparing them is a little bit heavier operation compared to comparing a integer. Okay, now the reason why is because think of a string as a name. Well, everyone's name is different and it all breaks down to the length. Okay, if your strings were letters, okay, and you only had 2, 1, 3, it would be pretty quick. But when you get heavier, as in like an M4 rifle, or let's say Microsoft. Well, when Unity or any program compares those strings, it has to compare every single case and go yes, no, yes, no. And it compares each individual character. What do I mean by character? Character is A, B, C, and so on all the way to Z. The reason why I did an integer is because it's one characteristic, and we use weapon slot 1, weapon slot 2, weapon slot 3. We don't use traditional the way we wrote it is we know what slot it is. Our script is actually slot 1. So we say weapon slot 1. So it makes it very easy to know what to write to because of the naming convention. Now the integer is to keep it similar so that we can write code that goes, okay, well this is 1. Okay, so we're probably going to go to weapon slot 1, right? We'll probably sit here and go weapon slot 1, right? And then do something. Okay. Piece of cake. So it tells us, it interacts with our slot script to do something. Parent, spawn weapon, do an animation. And the way that I think of it is, okay, our weapon managing system, okay, which has all of our slots, Okay, and then we use the switch statement, which is based on an integer, and we're just sitting there going, hey, do something in slot 1, 2, 3, you know. And the way that I really think of it is, think of your television, okay? Your television is like the weapon system itself. It does everything. It flicks the channels. It contains all the channels. It contains the picture information, everything that you need, that you want from a television. Well, when I think of an overriding class, a child class, I think of it as the remote on your television. Okay, your remote, you tell it, hey, flick the channel. Your television runs a function to change the channel, and it does everything it needs. So your remote is like a child class. You're overriding the logic in some form of way, or writing to a function inside the television class, the TV itself, going, hey, do something. So I'm overriding this little function, and these cases tell each slot what to do based on the integer. Now, the really cool thing about this is Light Gunner is a specialty class. This is every script like this will run it exactly this way. So we have a specific case of the Light Gunner. And we have our guns to interact with, or slots to interact with. And then these slots interact with our weapons. So in our Light Gunner class right here, we can go in and tell our weapon slots what to do. Do they have bonus stuff? Do they have a specialty thing that they can do? Everything that's in Light Gunner, we could probably pass in a special function, as in a bool here. And this is just an example. This is for bonus damage. Okay, we can pass a different type of spawning of a weapon in here, and because this is a overridden class and it's only for light gunners, or other stuff like heavy gunners do not get to write that function. They write a form of the function, but it's another overridden class. So in reality, it's got its own instance and it does its own functionality, which is really extremely nice for them, because now we have more cases to do things without doing if, else, or any type of evaluations like, hey, are you a heavy gunner? Or just basically comparing a whole bunch of cases, which makes our program run faster in the meantime. Because, you know, if you can make your if statements like disappear, you give your computer a faster speed to go. Think of it as a street. Okay, that street has all stop signs. Well, to make your street go faster, you could possibly use street, not stop signs, but a street light, you know, a red light or green light. So instead of going down and doing all these little stops, you Now you have a red or green light to go, where you can make 4 of those stops disappear by making them green lights, and then the other side does red lights. So you basically cut yourself down to 1 stop versus maybe 8. And that's how I always think of my if statements. Now, there's a really good reason why I use a switch statement here, and it is basically because of this default case. If there is not a written case for this, it will automatically go to default. So I have 3 slots in this class, so I'll have 3 cases. Well, the beauty of this is I can run logic that says, hey, you cannot pick up this weapon and use it on the screen for the player. I do not have to make if else, if else, if else for every slot that I have written out. Like if I made a master class and I put, can I use a medic? Can I use this? Can I use that? Can I use this? And so on and so forth. I have 9 different slots that I can use in this game right now. 9 different ones. So by doing this, instead of 9 cases, 9 specific things that I'm supposed to do, I can write, what, maybe 4 lines of code instead? And this will filter out all the bad stuff and all the good stuff by using a simple integer and a simple switch statement. Because I've got slot 3, and this is my example here. I have how many slots? There's, and I know I have more than that, but guess what? I have weapon slot 5. Bam, there you go. Weapon slot. And then it doesn't include my medic class. Okay, so that's 6 different cases right there. But because I used our switch statement right here, and it has this default method right here that says I can't do this, we can have 99 or 100 different ones, okay? 99 or 100 different slots, okay? And all these variations between them all, okay? When it comes to my switch statement, I only have to write the ones that are necessary for this class. So when I go down to this heavy gunner, the heavy gunner could use melee, no handgun. He cannot use a handgun. He can use a light rifle and a heavy rifle. I only have to write, what, 4? And if I had 99 different classes for slots, you know, I don't have 99 different if statements. By doing it in a switch like this, and I write the ones that I need, the default right here, when it gets to this integer, and it says, let's say this integer is 4, guess what? I never wrote a case for 4. So it goes to the default, which is, no, you cannot do this. Ha ha, see you later, buddy. Whatever. And it does nothing. It only pops up a screen. You cannot equip this. Makes it extremely powerful in a very way, because I don't have a lot of junk code in there that doesn't need to be there. So my CPU doesn't have to evaluate all that extra stuff. It only evaluates these little cases. And then each case can have its own special functions. I mean, you know, instead of... Which one did I modify? Is it slot 2? Okay, we'll make an example of that. Light gunner. Okay, well, slot 2, we've got other functions in slot 2 because they're things that we need. So we're going to go weapon slot 2 dot spawn gun. Okay, we want to spawn them. Or it could be add damage or anything else. I mean, it doesn't have to be spawn gun. Or maybe you want spawn gun bonus. Okay, instead of a normal spawn, you spawn the gun with the bonus, which in reality is the function that's just going to run and get the when it gets the component, we are going to interact with it in a different way. Okay, now because this is an overwritten method and it's in the light gunner class, this special case right here, this does not run any of this, only on the light gunner class itself. So when we go down to the heavy gunner, he will have his own little logic right here. Okay, and we'll use the default cases to filter out all the other just miscellaneous garbage that we don't want to use. Like the heavy gunner, he shouldn't be allowed to use a sniper rifle. You know, there may be a case where you want him to use the heaviest sniper rifle, like some 1000 caliber sniper rifle. That might be the case for it. Well, those extremely high powered sniper rifle thing, you can write specific code for that case and put it in a heavy gunner script. It's no big deal. Okay, by making it an inheriting class like that and making it where you can interact, it makes it very much more pluggable. It's like I'm thinking of it as like a universal remote versus the remote that's done by the manufacturer. Okay, and I hope that makes sense to you guys. And I think this is going to be possibly the end of this video. Yeah, I think it would be a good way to end this video without overloading your mind with too much information all at once. Okay, and that's the slot player. Okay, and here's another prime example. The basic player, I have a basic player, which is just a basic controller, okay? It's just the basic controller whatsoever. Now, and there's nothing in that. It's an abstract class. Basic player is just basically the basic player. Okay, it's a very basic controller. No running, just walking around and falling and stuff like that. No big deal, right? Well, when we overrided the class, because it's an abstract class, its design is to be overridden. Well, you don't have to override anything in there. You can basically have it call the base functionality, which tells it, hey, do everything that your original class does. So basic player, it calls the start method here. Okay, no big deal. Speed, adjust speed equals false. Well, adjust speed is a bool, and it just returns a float. Okay, so yeah, that's cool. And then, well, when we take our key, which is our running key, which is basically the left shift, like most games, we just run this function one time, speed, adjust speed. If it's true, we return, hey, it's true, we're running. Then we return the running speed. But before we do all that and everything else, notice this base.update right here. This is going into our basic player and running all this code right here. That's what it's doing. Okay, and it's doing else if input dot get key up, then we would do the speed adjust again. And this is basically our running class. Very easy to do and very simple to evaluate what you're doing. Now you're probably like, well, how do we get this basic player? Because an abstract player cannot be instantiated into the world. And you know what? That is a very, very good question. And I believe I solved this. It's a player walker. Now, notice this player walker. It sends what? What? If I run, it shouldn't be ascending from run. Run player? No. It should be ascending, it should be inheriting from basic player. Player walker from basic player. Okay. So, like I said before, our player walker, which is just a class that just does, it can only do one thing. It can walk, run, jump. It's just the basic controller. You hit shift, it will not run. You just walking around like a little civilian. If that's the way you can think of it. And like our heavy player right here. Here's another one. It only has this stuff right here, and you're probably looking at it like, well, that's kind of weird, but why am I just doing it that way? It's because if I want to make some specialty thing, like he can't climb ladders, then I need a specific class to override and do certain things. Like our basic player right here, there's no logic whatsoever for climbing ladders inside of it. Now our running class right here, player running, we may decide to make a medic player, okay? Which the medic player may go and be able to go up ladders, may be able to go on platforms and move around and stuff like that. The heavy gunner may have platforms but can't go up ladders, which makes sense. He's the guy who has the heaviest weapons, so he cannot climb ladders and stuff because his gun's too heavy. He can't do it. I'm cool with that logic. I mean, but I guess that's all on how you want to design the game. The point of these videos is to show you a more pluggable way where you can take code that you've already written and extend it or overwrite certain things to make more of a, I want to say a library thing. Use code that you've already written in such a way where you can extend it and do way more things with it than the simple thing of, hey, I wrote this script right here, this is what it is, and boom, there you go. And it, because if you have to write a different script for each individual thing, it's going to be very problematic to interact with everything. Okay, going from one script to the next, and then all the different case studies. Okay, let's use this as an example. Okay, let's say you want to damage a player. Well, if you have a script for a heavy gunner, and you go heavy gunner health, and then light gunner health, and heavy runner dot health, all the different types that you have for players. Okay, let's say I shoot you. Well, what am I going to hit get component for? Okay, hit dot get component. Am I going to go for heavy gunner, heavy player, heavy what? I mean, what's the case study for that? Well, most people will be like, well, all you have to do is do hit dot get component. If it returns null, then do hit dot get component, and then hit dot get component, and then hit dot get, and they're like, got all these if statements or if dot get type. Well, I'm sorry, but that doesn't do it for me. I mean, it's very, what, I'm gonna have like 10 different case studies for every different type. It's not cool. Then you're like, well, then you can do a hit dot tag. Well, hit tag health, do this. I mean, the whole idea of it is to show you guys a way to get around all those cases where you need different components and you can't interact with anything. Okay, so, and there's an email for me, somebody for me to help build a game. Well, honestly, I see a lot of entangled code that can't interact with multiple scripts across the board. It's not going to be very easy for me to write something for your game. Now, you might not like the idea, you might hate it, but the more that you write something for one specific case, then later on you cannot interact with it for another reason. So I hope you take a good look at these tutorials and think about, hey, how can I make this better? How can I make this more versatile toward multiple different cases versus, here's a good example of how you can make something a little bit more pluggable. Take this right here. I have a tag weapon which takes a string tag, a transform, and a hit point. I am actually going down here and I have a specific function that does, now I put it in the base class because this is something that I believe should be in the base class, because this is going to be done for a lot. We've done it based on a switch, okay, and we use a string, okay, because it's the tag, there's nothing else I can do. Well, this case.movable, it does this. Well, case.mpc does this. Now, like I was saying, for hit.get component, if you're only trying to damage a item, well, if you're only trying to damage an item, you can put a public void method in every single script that you wrote that's different. You can put damageable, and then make the script take a float. So when it hits this void method that's public, it takes your variable in, and then you can do the damage thing. Now, see this send message? This send message is looking for a void call instead of a script like this right here. And then here's the default case. Notice there's nothing there. Well, I don't have all those weird cases in here that would be everything in the game. I only care if it's a movable tag or an NPC tag. If it's a player tag, it ignores. If it's an environment tag, if it's default, it doesn't care what tag it is until it's movable or NPC. So I basically took this and completely took out a ton of cases for it. So that's a good example of using a switch statement to do specific things right there. Which this right here makes it a lot more versatile. The only problem is you have to make sure that you have a case for something that you want to do. If I do a case dot, let's say I want a tag in there that says this is a shield, okay? Well, in the shield, I want it to do a particle that's sparse. So I'll go probably target dot transform dot position in an instantiation. You just basically go right into the instantiation. Instantiate the particle system at the hit point, which you already have right here. So there you go. But I'm going to get off this video and probably doing a little bit of studying for school and things like that, but I'm also going to think about a better way to explain some of the functionality for weapons and things, because I may not have it the way that I would like. So take care, guys, and I hope you liked the video. Hit like, subscribe, do whatever you guys do on YouTube, and thanks for your support, and I hope to hear some comments or questions and things. So peace, and enjoy the rest of your day or night or good morning. Bye.